This series will cover all the Nexus. Basically, it will cover the Nexus series. So it will give you an idea about how the Nexus series works, what are the different platforms, and where we can use all the Nexus switches, and what are the technologies that we can work with Nexus switches, like for example, VDCs, VPC, then overlay protocols are there, VXLAN. Then we will also go through some of the API calls as well. We will see how we can control, or you can send commands to a Nexus switch using APIs. So we will also touch base on the security factors that revolves around Nexus switches. And we will also do multicasting, how multicast basically works, and how we can configure them in the Nexus switches. And then first, how redundancy protocols, how we can configure them in the Nexus switches. We will also going to implement some of the routing technologies like OSPF, BGP, and we will see how we can configure them. So we will cover all of them one by one. So this is just an overview what we will be covering in this particular uh, training session. Uh, so there will be multiple modules that we will be covering, and this class is we are taking as the first class. So this is considering as the module 1. So we will be identifying what all the Nexus series are. So what are the Nexus switches, or what are the platforms they are using? Um, for example, how many series are there? So all those things that we will be looking into. Uh, There will be a separate Q&A section that we will be bringing up later. Once our session is completed, then I will be bringing that up. So that if anyone have any questions, then you can bring that up, and we will try to address them one by one. Okay. So you have all got an idea, right? What we will be covering. Okay. Okay. Now let's start this session. So again, I will reiterate again. So good afternoon and good morning to everyone, and welcome to our session on this Cisco Nexus platform. In this module, we will walk through the key Nexus switch series that you will commonly encounter in the data centers, right? For example, the 7000 series switches, the 7700 series switches, 7700 here. Then we have the 5600 series switches, 3000 series switches. 3000 is a little bit different. It might not fit everyone, but I will surely going to go through them as well. 2000 series switches are also here. These are what we call as the fabric extenders, FEX. So we will be using them as well. And then yeah, so those are all the things that we will be covering. So also we will be using some of the comparison charts and use cases, and see where we can use them one by one. And then we will having the summary of what we will have done till now, and then we will have some quizzes and some Q&A. Okay. Now, before diving into specific models, let's talk about why Nexus even exists, right? So unlike traditional uh, catalyst switches that are primarily built for enterprise LAN environments, Nexus switches are designed for data centers, right? Their main purpose is to work on the data center.
Arjun, this is today's agenda or a complete training agenda?
This is today's only.
Okay. So 9,000 we'll cover on later on.
Yep,
Okay.
we will have a separate class for the 9000.
Okay.
So yeah, so unlike traditional catalyst switches, these Nexus switches are designed for data center environments. So these switches focuses on high throughput, very low latency, and high availability and scalability. So that means if we summarize here, so that means the main purpose is to give us high throughput, right? We need high throughput in the data centers and very low latency in the data centers, because there will be fast switchings between the servers. And if you are working in a globally accessible data center, then you have to make sure that the customers are not impacted because of low latencies. You will be finding some of the interfaces going up to 100 gigs, right? There are 40 gigs interfaces, 25 is normal. So all those things you will be seeing. So, and they are highly available. So we have to make sure that they are either we have different hs configured for them. And how we can address them, there are different technologies that we can use for ha. For example, we can use uh, what they say, we can use virtualization. We can for example, vdcs, we can create vdcs for them. Then we can use load balancing mechanisms, so that we can have different chassis which can do different which can basically load balance the data. And we have scalability thing. So when I say scalability, so that basically means that the data centers that we are building, it is it not going to stand around like that for much long. Like for example, if I have a let me clear this up. Yeah. So for example, if I have a data center right now which is kind of currently using chassis, for example, we have a small data center that we are only using 2 racks, not more than that, right? Suppose this is rack 1, this is rack 2. We have servers deployed here, we have Nexus switches deployed here. But in the future, as it expands, we will be putting up more racks, more and more racks here, right? As we put more racks, we have to make sure that it covers all the expansions that we do. So that's why some of the Nexus switches that we will be seeing will be highly scalable. They will have modular modular slots where we can put different cards in it and different capacity of IO ports, which can be used to further connect to different servers. So that gives us a very robust design so that we can scale according to the data center as it grows. So you will also often hear terms like VPCs, that we call virtual port channels for redundancy. And you will also might have heard FEX, fabric extenders, that is also being used for scalability. And also you might have heard about VDCs, but if not, then we will be going through them as well. So VDC is what I have told you, it's a virtual device context. We will be using that for multi-tenancy. Right? And obviously we have the NX OS, which is the Nexus operating system. Cisco designed Nexus platform to support modern data center needs, including virtualization, automations, and storage conversions. We will also going to see how we can, connect storage network like using FCOE. So we will also be covering that.
You're on mute, Arjun.
Okay. Can you hear me now?
Yeah.
Okay. So I was saying that if we have cleared this part, then I will be moving on to some of the series right now. Okay. So let's do this. So one by one, we will be, uh, let's take the next slide. So this is what we have discussed right now, the why we need Nexus switches, right? And then we have another slide which basically gives us an overview, like what is Nexus and Catalyst, what is the difference between them. So here you can see, just as I have informed earlier, so Catalyst is more around enterprise network like campus LAN, where we can use them. The OS that are being used are, what they have is called iOS, and here what we have is the Nexus, NXOS. So there's a difference on that one. And then we have the VDC support. So unlike, we cannot virtualize the campus network, and here we have the ability to virtualize our physical switches. Here we have use of FCOE that I have told you earlier, which can be used for storage, connecting storage network using an MDS switch. We can connect it using the FCOE technology.
There
And
are a
then
different switch for FCOE or same switch we will use.
same switch we will use, the 7000. So
What is FCOE?
fiber channel over Ethernet that we can use to connect to a storage network.
Okay.
This FCOE supporting all like 5K, 3K, 7K on all
Yep,
series.
yep. I mean, yeah, at least we can do it on the. It is not supported on the. Yeah, it is supported on the 5K as well. They can be used them. We can use them on the 5K as well. So we will be covering that as well.
So, but why you have given it is in the limited one, in the catalyst one?
Yes. So I mean, this campus LAN switches, there are very little hardware which could do that. So that is why it is saying limited. But in data center, like in the Nexus switches, they can be, it is available on all the versions or all the hardwares. But also the limited here is like, we really don't use fiber channel over Ethernet in a campus LAN. We don't need them. If we need to access any storage, we can do that using a LAN anyway. So, and it is not mission critical that it has to be using FCOE for connecting a storage network. And literally, I haven't seen in my career where a LAN, where a enterprise LAN is using FCOE to connect its own storage network, which is limited to that particular site. Right? Obviously, some of the um, basically the sites will have their storage uh, stored in the data centers where it is globally available to all the clients that is particularly being used by that that is being used by that particular site. So for
Uh,
example,
So, but now they are be using the clouds, no, sir. So, what is the use of the storage centers?
no, cloud is something else, right? So cloud is new, right? There are still sites, and there are still, you will find in your career, or there will be some clients available who are still using the legacy, or you can say the existing data center model on the what we call the on-prem. They are still using on-prem data structure. It is
like
not that.
bank and all. Like
Yeah, the banks and there are different models. So for example, if we can have totally clients who are on cloud, you will find hybrid model as well, who will be using this model, like you have said, banks and other restricted data that they cannot put it in the public domain, public infrastructure where they cannot have control on. So they will like to keep their highly secure data on their own on-prem data center, and some of the others that which should be available globally can be accessed, and they can put them in a cloud environment. And some of the data centers will strictly be on-prem. So there are different models how they access, and it is not like you will find every and every client will follow one of these three models in a data center world. So it is not that
So that FCOE is having some kind of different SFP like
yeah,
or
no,
how it looks. Basically, how it looks. Do you have any picture?
sorry, how it looks.
Yeah, that FCOE port. Maybe it is a port, right?
No, this is a technology that we can use. So it's called fiber channel over Ethernet. So it is not a different port overall that you will be seeing. It is just like normal SFPs with fiber ports, but the technology that we will be using is different. You won't be able to see it visually what you are
Sir,
working on.
but we can configure on the routers and switches.
Yes. You can configure. It's a virtual configuration, but the thing is, there is nothing physically that you will be seeing. Oh, this is an FCOE port.
Okay, so after using FCOE, what difference we can see? Like the fiber, like what exactly it will we can achieve from this?
For which one? For FCOE?
Yes, yes. Like suppose we have a fiber port, we configure this something for FCOE on that port. Like what we will achieve.
So, okay, so I'm sorry. So basically, FCOE is like, for example, it will be great like if we can transfer the data from fiber channel to Ethernet, right? So that we can transport the SAN traffic, what we call is the storage area network traffic, from one place to another. Normally, what happens is like when we build a SAN network, it's totally different. It's a totally data center network we are talking about. It is, what we are trying to go into. I will just give you an overview. So SAN traffic is totally limited to the SAN network, which will have their own MDS switches. They will have their own servers, or some of them will be using maybe Unity, a Pure. So they will have their own storage, devices, and they uses their own technologies to transfer the traffic from one device to another, right? and and in order to take that traffic.
So different types of SANs we are using till now, because
Mhm,
now it is being totally being cloud. So they have been using the data centers. They have been installing all over the world.
mhm,
So different types of what we call the SAN networks and sandboxes that we are going to use in the
mhm.
real world, because
You
different
will,
types of sandboxes will be using will be.
right, you will be using different SAN. So when we say SAN, storage area network, it is totally different than the one that we will be covering. So basically, storage area network is something that will be, some in some in some agency or in some companies, they totally have a different department who looks after the storage network, right? As a network engineer, you might not even to go there. So SAN traffic or storage area traffic, it's a completely different architecture. It's a different uh, session. I mean, it's a different project. Sorry, it's a different, what we can say, course that we can go through. It's not even related to what we will be doing here. But the technology that we are talking about, FCOE, is what I'm talking. Like if we want to integrate the SAN traffic with the on-prem traffic using a Nexus switch, you can do that using the FCOE or the fiber channel over Ethernet terminology or technology that I'm talking about. So some of the requirements that here are the jumbo frames will be needing FCID, uh, and also there will be and uh, the minimum bandwidth that is needed to run FCOE is 10 gigs, 10 gig per second. So we cannot go less than that. So there are lots of devices from 5K to 9K that supports FCOE.
So,
The
but we
2K,
can use the load balancers to control the traffic.
yeah, but no, what you were saying right now, what do you want to control the traffic using using load balancer?
Yes, because if different types of if multiple users want to uh, attack different want different types of users and different type of locations, if they want to access the data at the same time. So if we
Hmm.
want to control the data,
Yeah,
in the
that
sense,
is what you were talking about is a overall architecture in the data center, right?
yeah,
So so that is a data center course that you were talking about, which will include everything. It will include I know it will include the storage area network. It will include the load balancers and everything. So I mean, what you are saying is, if some clients or if some users come to a data center, obviously there will be load balancers and there will be proper load balancer devices. There won't be nexus. There will be proper
actually yes, sir, because there will be no nexus, because nexus will not be there in the data centers,
no, they will
because
be there. The purpose of the nexus is different. The load balancer that you're talking about, its purpose is different,
oh,
right?
so so the difference is proper difference. What how can we distinguish between these two?
The load
Because
balancer, the load balancer that you are talking about is a completely different technology that it works on. It's for example, right now I think we have some of the vendors that that provides load balancer F5, I know NetScalers, so Barracuda. So all those are some of the vendors that provide load balancer. And load balancers, if they are dedicated load balancer, which can be used as a global level or as a local level as well. For example, if we talk about F5, so there are different load balancers that can be used to load balance the traffic that comes from the outside and are going to your to your server farm. So there will be different lots of servers who will be, engaging the connectivity from the outside. There won't be only one server, right? So when we talk about a global data center, there will be lots and lots of servers there, and in order to load balance the traffic between them, there will be load balancers. What nexus do is totally different. What we are talking about here is nexus is for routing, right? How we can route the traffic between the servers to other to other modules. Like for example, if the traffic needs to go to a firewall, how it can how it can shape or route the traffic.
but
And for
we can
example,
use the but we can use them before the networks. We can use the firewalls, because if we want to eradicate the unused traffic, or we want to eradicate the misused traffic, mislead traffic, in the sense, if anyone wants to attack our company or
there will
bypass
be
the network.
firewalls for them, right? There will be dedicated firewalls for them for to police the traffic. So you are combining everything. So, okay, so like you were saying that for security there will be firewall, for load balancers there will be load balance. I mean, for load balancing there will be load balancers. For when for WAN aggregation there will be WAN routers. For internal core switching there will be Nexus switches that we will be using instead of our regular switch that we use in our network. Just replace them with the Nexus. That's what we use in the data center. Okay, we will be needing some devices to switch traffic, right? So that are the switches, and instead of using the normal catalyst switches, we will be using the Nexus switches. because Nexus provides a whole different things that we can implement to support a data center that a normal catalyst switch cannot do.
Okay, so understood.
Okay. Okay. So yeah. So now let's go to one of the one of the series of switches that we have. For example, the 7000 switch. Yeah. Okay, so let's start with the Cisco Nexus 7000 and the 7700 series. So these are the big chassis modular switches that we are talking about. These switches are the modular chassis. Okay, these are the one which have have slots, different slots that we can put in different cards, and based on that we will be having how much interfaces we will be needing for that particular switch. So these switches are used in the core or the aggregation layer or large scale data centers. So they are modular, like I have told you, which means you can install different line cards and supervisor engines depending on your need. And then we have some of the key features which includes these switches that it can support is like VDC that I have talked earlier, but we will be going through them as well. So it lets you run multiple logical switches on the same physical switch. Then we have the fabric modules and the line cards. This defines the performance and the port types. And we have redundant supervisor engines for availability. Okay, so that we can, so that if one supervisor engine goes down, it can move to a different supervisor engine and it can still keep the switch up. The Nexus was the Nexus 7000 was the original platform, and the 7700 is a newer one that we are using right now, is a new high performance version. The 7700 series, it supports higher bandwidth. You can say it supports higher bandwidth, and then also it can support newer line cards with better throughput. So it can go up to maybe 100 gigs, right? Different line cards will, different line cards will be there, which will be used to provide 100 gigs of throughput. These switches are very ideal when you need high scalability, because since it is modular, as the data center expands, we can put in we can put in more slots, or we can put in more cards in the slots according to our need. For example, if we have bought a Nexus 7700 series switch with suppose we have 6 slots here. Okay, and currently, as per the need right now, because of the budget constraint, we have put in 2 slots. We have, suppose we have put here 32 ports of 2 slots, so we have got 64 ports, right? And these are still available. So that means as the data center will expand, we can put more and more cards here, and accordingly you will get more and more ports to connect to different services.
Arjun,
Okay.
very basic question. Sorry to ask. So I'm new to
Yeah.
this data center. So you want to say in every slot we will have a line card in this?
Yes.
Okay.
In every slot you will be having a line card.
Okay.
So this, you can say this particular switch, let me see if I can get a diagram for you, okay, from the Cisco side. You will be able to see that what I am talking.
Yes, yes. I also want to link the terms which you are using through the diagram.
Yeah, can you see this diagram that I am showing right now?
Yes, yes.
Okay, So this is a 7,000 series switches. Okay.
Okay.
Their diagrams are a little bit of cranky because Cisco doesn't put very high defin images. So this is what we have got. Anyway, so here you can see these are the line cards that I was talking about. Okay. And these are the slots. Suppose this big one have 16
Hmm.
slots.
Okay.
Okay. This one have 16 slots.
Okay. And
So as per need, we can put and as per budget, we can also put create. I know we can also buy smaller devices with smaller slots. But basically,
Mhm.
these are what we are talking about. These are the slots, and these are all modular. You can this you can see this this handles are basically clickable. So once you raise these handles, this slot will come out.
Okay. Okay.
It will come out, and if you wanted to put more slots, and for example, if you bought this chassis, and if
Mhm.
you have bought only 8 cards, then you will get this installed, but this will be blank slots here. They will put some steel barrier here with
Yeah.
some screws that you can remove it and insert any modules that you needed in the future, so they will remain blank. So as per you scale your data center grows, you will have to put more and more line cards here accordingly.
Mhm.
So this is a single switch.
This is a single chassis switch, yes.
How many supervisor intent will be there in this single switch?
You can see here we have two. This is one, this is two. Every 7,000 we have two supervisors. Here also you will see two, one here and one here.
Can you please give us like simple architecture, like how this supervisor engine work with this line card and how the traffic flow basically?
Yeah, sure. So I will remove this first.
नहीं 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 पापा कह रहे स्लीप नाउ बहुत लेट हो आना ऑलरेडी हो गई तो आपको जरा भी बैठना आप ऐसे कर लेते
Okay. Oops. Okay. So the and what I'm going to tell you is basically true for all the Nexus switches. This is the architecture, how it works. Okay. So the Nexus OS is basically the combination of what I was talking earlier is the SAN OS that the MDS series of MDS series of Cisco devices uses, and the iOS switches. So it is both layer 2 and layer 3 capable. Okay. And in its architecture is very modular. For example,
So can we see the traffic whether if you're going to the MPLS, uh, can we see the traffic whether how much time it is taking to pass to the channel?
uh, I mean, yeah, you can ping any IP, then you will get the latency, right? For example, if you ping
So
an IP,
through Python language we can check the uh, we can check the ports and what will be the latency we are getting. So if we want to increase, we can increase with through the MPLS and OSPF.
I didn't get your answer. I'm sorry, didn't get your question actually.
Sir, actually you have it supports MPLS, no sir,
Uh-huh.
through the channel.
MPLS is on the WAN, right?
Yes, sir. So when so in that also we can check the uh, timer. So how
Yes.
much time it is getting to travel
Uh-huh.
the packet, how much time is taking to travel to the other port.
Mm-hmm.
So
Within
we
data
can,
centers, yeah, within data center, between one switch to another, you won't be, I mean, you won't be able to see very high latency anyway. It will be very less, in 0.0 something milliseconds, or maybe even nanoseconds.
Nanoseconds, because I have
Yes.
done that.
Yeah,
Because
you will see that in nanoseconds. Yes.
in the Python, we have used the Python language,
Mm-hmm.
where the given the latency is, so we have changed, because the latency, the data traveling is taking too much time, and it is colliding with the other data. So
Mm-hmm.
we have changed the latency time
Mm-hmm.
to get the proper data with the network.
Yes. So how did you change the latency?
So with the Python, in the Python programming, we have that, because it will be given in the Python programming itself.
Yes, but what is did you did to change the latency? That is what I'm asking.
So it is given in the timer. So how
Timer.
much time it is, sir? Because in the Python programming, it is given the how much time it is taking to travel. So there
Mm.
will be a timing will be given. So whether it is taking 10 seconds or 1 minute, so it will be given in that while
That is a
programming itself.
control time. There is
Yes,
not the
sir.
data time, right? Data flowing
Yes,
time.
sir.
I
Yeah.
think the data flow time is in the millisecond, sorry, microsecond or nanoseconds.
Microseconds.
Nanosecond.
Nanoseconds maybe.
So sometimes when you process data, it takes time within the device itself. It is not the latency that we are talking about that flows from one device to another. Because when we talk about latency, so it can be like, for just give you a small definition here. So for example, this is the source and this is the destination, right? So when the traffic flows from a source to destination, it will incur some latency. And this latency comprises of two things. One is the processing of the individual devices that will be here, and plus the bandwidth latency that is actually traveling through the interface. Now, both of them comprises the latency that this source will face. Like, for if there is a firewall here in the middle, and if the firewall is doing some kind of inspection for this traffic, then you will be seeing some milliseconds of latency that will be levied by this device. Right? So accordingly, and accordingly, if it is going a higher, if it is going to a longer distance, the bandwidth latency will kick in. So there are different things that will include a latency that we are talking about. So, I mean, it could be lots of different things, and latency troubleshooting is not very good. And because it is something that takes, time, effort, and if it is not there visible in a given time, it is very difficult to troubleshoot if there is any kind of latency on a network. But yeah, um, this is what I was talking about. Okay, so the NXOS architecture is basically is a combination of SAN OS and the normal L2, normal catalyst switch. So here we can see the base of the OS that it is using is Linux. So it is not using any proprietary language for building the Nexus switches. It have its Linux kernel in the end. So you can go into the shell command as well. If you do the shell command, you will be able to see it. So, so this is a Linux kernel in the middle, the base. And then we have some system infra here, like for example, stuffs like that are necessary for the operating system to run. And then we have converted this sections here. So you can see we have a HA manager, we have an L2, we have an L3, and we have a SAN area of the OS. And these are all managed by this HA manager. And this is what we call as the supervisor. Okay, and it have its own processors basically. And so So this system manager that we are talking about, and let's check some of the major components of this system redundancy that we are talking, which makes the Nexus OS high available. All these components are built into the soup engine. So is the system manager, its job is to launch, stop, restart, or monitor the overall services that are running on the on the Nexus box. Suppose when the active soup happens to goes down, it is a system manager which will monitor it and makes the switch over to the secondary soup, or I mean the secondary supervisor card, uh, so that so that the chassis remains up. The system manager also monitor its old health as well, just to be sure that he is alive. And then the storage that I'm talking about is what we call as a PSS. Okay, so PSS means persistent storage service. So it's a database. It is storing all the information from all the services. Like example, you will see here in the later course, there are different services. For example, VDC have its own services. VPC will have its own feature services. So all those services data that are collected by this device will be stored in this PSS. This helps in retaining the stateful information to be stored in the secondary soup in case we need to do a failover. I mean, between the soup engines. Okay, and and you might be asking like how the data flows within the system. So it uses a technology called MTS. Okay, so MTS means a message and uh, transaction. Okay, message and transaction service. So message and transaction service, it acts as a mail carrier for all these components. Suppose if any service from the soup, from the active soup needs to write something on the secondary soup, it will need its help. So this basically being used by the um, by the soup engines to carry the information from one service to another. Okay, now when the traffic flows, as I have told earlier, I'll just clear this out a little bit. Okay, so I think I have told earlier that we have two things. One, what we call as the IO ports. This is the line cards. Okay, that we call as the line cards as well. And the other thing is the fabric module. So line card and the fabric module are needed to transfer the data traffic within the switch. For example, if this is a switch here, I have drawn here, and this is suppose one port, this is another port. Okay, port 1, port 2, and this is the fabric module, suppose, and this is the line card. Now, if any traffic comes in to this interface and it needs to go out via this interface, how it will go? So it will come into this interface, and this traffic will go to the fabric module, and the fabric module in the backend will send this traffic to this interface, and this traffic data will come out via this interface. Okay, and all these sections are being monitored by the supervisor card, so that it can retain the information what is happening between the services, and if anything goes down, then it will make sure that it will take the redundant card available for this. So for example, for the fabric module as well, uh, as many I mean there are different modules for fabric as well. So if we are putting up more and more ports, we also have to make sure that we are putting adequate fabric modules, so that there are so that when the traffic comes out from one interface, there is no latency observed within the data within the particular chassis switch, right? If there are less number of fabric modules and more in line cards, then you will be able to see some kind of latency coming from one interface to and going out by the other interface, because there will be different CPU cycles that will be going on this particular fabric modules. So we have to make sure that the fabric module and the line cards are in sync.
So there are three components: fabric module, line card, and supervisor.
Right, right.
And
So
the
and
supervisor engine is like the brain of all, which handles, monitor all these fabric module and line,
right,
right?
right.
Uh, okay. Like line card is just like L1, like it doesn't do anything.
Yes. Yeah, yeah,
All the
yeah.
things done by the fabric module.
Yes. So all the no the fabric model uh, is to handle the traffic within the switch, right, from one interface to another. But the routings and everything, all the brain will be in the soup. This is the control plane.
Okay. Forwarding is done.
You are breaking up, ma'am. Is it me or?
Yeah. Excuse me, I have a question.
Yes.
Do we have to install the fabric module just like we install the other, line cards?
Mm-hmm. Yes.
So
We have to.
there's a
Yeah, we have to
there's a
install
space
fabric.
for fabric module on the chassis.
Yep, we have. Let me get you one diagram as well for that one. Let me
Okay.
see. That might help. There was one. Let me see. Yeah, one moment. Let me clear this up. Oops, it's very big. Can you still see my screen? The screenshot that I have put here?
Yes.
Okay, great. So yeah, so here you can see this is one of the 7000 series switches, right? And these are the line cards that I was talking earlier. And here are the ones that you can see are the fabric models. Okay. And these are the ones that are the fabric. You can see these are also scalable. Here you can see this particular block, it is empty. So that means as we put more and more line cards, you will be putting more and more fabric models as well. Okay, so these are the soup engines here at the top.
Okay.
And these are the line cards. These are the line cards. These are normal RJ45 ports. Here you can see these are the SFP ports, and here are some other ports as well. So different lines card supports different ports and functions, and we will be having a what we get the modules as well. And how basically this works is it's something like this. Um, just giving you a 3D view of the Nexus switch. So for example, my drawing a little bit bad, but I hope you guys will understand that this is suppose this is a 3D model of the Nexus. Okay. Now at the this is the front. Okay, and suppose this is the back. Now in the front, you will be seeing some line cards that we will be putting in. Right? These are the line cards that we'll put in. There will be different interfaces, IO ports here, right? And here we have a fabric module plane. You won't be able to see it, but it is there, right? This is in the middle of the switch. Let me see if I can get a different color. So this is the fabric module plane that you will be not be able to see, but it is there inside. It might be in the middle of it, right? So this is a plane. So and all the fabric modules will be terminated here. Like if we put them from the back side, you will be seeing that connected here like this, right, in the back end side. So this plane and this line card are in the same, you can say in the same horizontal plane. So this is a 7K that I'm talking about, right? So all the traffic that comes in like this to this interface will be sent to the fabric module, this plane, and the traffic, if it needs to come out via this, then from there internally it will come out here, and the traffic will then come out from this interface.
It means that fabric is taking care of control plane.
Control plane is basically, it will have all the routing policies, switching information, how it needs to handle the traffic. This is actually the data flow that I'm talking about. And then, yeah, so this is the forwarding plane, for example, not the control plane. This is the forwarding data plane. And if I have to go step by step, for example, the traffic will come here in this interface. Then if the switch doesn't know, if it doesn't have any cache memory for this traffic, it will look up to its control plane, right? It will look up to its control plane here, and suppose, hey, I don't know how to deal with this traffic. Then what we'll do, the traffic will be it will not go to the control, it will be sent to the control plane. It will check what needs to be done with this traffic, and once it's been once it know what needs to be done, it will be sent to the again to the data plane. And the data plane is the same thing that I'm talking about. Data plane, it comprises of both the fabric module and the IO ports, right? It will be sent to the fabric module, and then it will come out via the interface, whichever it needs to goes out. If it goes out via this interface, then it will come out via the same one. If it needs to go out via a different interface, it will go out via the different one. But the traffic, the data traffic that flows within the chassis is controlled by this fabric module. Okay, and this control plane is basically telling what needs to be done with this traffic that comes in, and the data, actual data flow, will be handled by the fabric module. Did you understand? Did you get it?
Yes, up to
Yes,
some
sir.
extent.
Okay, okay. Okay, great. So moving on to the topic here. So so this, we are talking about the 7000 series switches, right? Okay. Now we have done our 7000, how it basically works, and this series supports higher bandwidth, like I have talked about earlier. We will be going through different line cards in a later classes, okay? And because there are different line cards actually that we can use, so we will be covering that in a later class. We will be showing their differences as well, so we will be covering that, and based on line cards it will have different throughputs. Now this switch are ideal when you know okay, so I won't be answering that, so you guys tell me, where in the data center topology would you like to place an Nexus 7000 or 7700 switch? So you have understood like how it works, like you know that it's highly scalable, you know that it's modular, it can run different features, VDCs, it have redundant supervisor engines. So where do you think that it will come in a data center?
At the core level, at the core level where all the traffic are coming.
Yes, right, great. So yeah, so we were expecting the 77 or the 7000 series in the core layer, right? So this is where all our traffic is traversing through. Yeah. So for example, um, I'm just giving an idea about a modular network design. Suppose this is the, let me clear this up a little bit. Suppose this is the core, okay? Whenever we try to design a network, we always, forget about how the legacy network works. Like, so in our normal enterprise or the LAN section, you know that we have a core, we have a distribution, and we have an access, right? It's very linear. We know that this is a linear design. Here, we wanted to change it. And how we wanted to change it is like, suppose we wanted to make a modular network. And when I say modular network, that means everything can be plug and play. Like, this is the core, and we wanted to create a WAN section here. We want to create a DMZ section here, because in data centers, you will be needing DMZ. And then we will be maybe having a VDI section here. So VDI means virtual desktop environment. Okay. So we have a VDI network here. We have a DMZ network here. We have a WAN network here. Maybe we have another one, maybe security section might be here. So you can see, and some, suppose you have an internal network here as well. So you can see here that this is a what we call a modern design. So that means all the sections that we have created are very modular. That means if we wanted to add anything to the VDI network, we can just add here. We can just keep on adding here, and the core will be taking it up. Similarly, for the internal, we can just add more and more things here, and the core will take it up, right? And this, suppose any traffic is coming from the outside network, right? Any, let me take a different color. So any traffic is coming from the outside. So we will be, we will obviously would need to police the traffic and see where the traffic needs to go, and accordingly filter the traffic or allow or deny the traffic. So we will be wanting that traffic to go to a security module. And when I say module, it's from a design perspective, not related to Nexus. Okay. So when I say security box, so it will send the traffic via the core and it will go to the security. So this security will then check where the traffic is going, whether it's allowed or denied, and accordingly it will send the traffic. Suppose it needs to go to the DMZ, so it will then go to the DMZ, and from the DMZ again it will come back security, and it will can come back LAN. So this is how we try to build any design. Now in the future, you might be thinking, oh, I think we need to add one more section in this design. For example, maybe we wanted to add uh, maybe one more, add a VDI, or maybe a Citrix server pool, right? Suppose then what we can do, we can just add one more service, one more module here, call this as, it's not looking good. Yeah. So suppose we have a call as servers, right? We create another pool here of servers, and we just connect it to the core, because the core is already have access to all the services here. So this is what we call the modular network design, and it's very highly scalable as well. Suppose suppose we have already filled up all the subnet for this server pool, then just create one more server pool and just connect it to the core, right? So this is how we wanted to design a data center network. And you can see this is not a linear design. This is a very modular design where we can connect all the things to the core. And that is why we expect the core to be highly powerful so that it can send the traffic in all directions correctly. And it has very high throughput and also very highly scalable and obviously fast switching. The Nexus 7000 can switch traffics in nanoseconds, right? So that is what we will be using in the core layer. Now let's move on to one of the next switch that we have is called the 5000 series switches. Okay. So 5000 series switches, these are not modular. Okay. Now these are fixed switch platforms, meaning it's not it cannot be suppose in the Nexus 7000 how we put line cards into the chassis. It is not possible here. These are fixed form factors. You cannot expand as per your need. If you need more ports, then buy a completely new 5000 series switch. Okay, so that is the reason these switches are not used on the core. These switches are the go-to, or they are very widely used as the top of the rack switch deployment. So when we say top of the rack switch, that means suppose this is a rack, or we have different slots here on the rack where we have servers here, server 1, server 2, server 3, server 4. Here we have suppose the power supply unit. So here we can put the 5000 series switch. Okay, and this is what we call as the top of the rack switch. Each rack similarly will have a 5000 series switch. Why we need them is because suppose somewhere in the data center, suppose after 7 row of 7 row of cabinets, there is another cabinet where you have the core switch, right? Now you don't want each and every server connection goes through your patch panel and then go through the core switch. There is very long cable needed and it is not ideal. If something goes wrong, then and also uh, it is highly, labor intensive work. So instead of this, what we do, we will be simply we will be simply using this core. So we will be simply using this 5000 series switch to connect all the servers to this one. And from here, we will just put one cable directly to the core like this. Less work and less maintenance. Okay, so this is the basic purpose of a top of the rack switch. And you can say like these are the access layer switches. In smaller data centers, they can be used ideally they are not used in a core, but in a large data center, they can be used as the distribution layer as well, what they call putting some 2000 series faxes as a top of the rack. But ideally they are what called as access layer switches, where all the servers or the hosts are directly connected to this switches, to this 5000 series switches. They can be one rack unit or they can be two rack units. So that means they can take up two spaces on the rack, or if you have bought a single switch, single line card switch, then you will be might have a single rack unit switch.
How many ports are there in this by default?
Sorry, how many ports?
I'm going
So
to
yeah,
laugh.
Yeah, it depends. So when I say it depends, like they will have different models of 5000 series. There are lots of different 5000 series models. Some of them can be 24 ports, some of them can be 48 ports, some of them can be so basically there are 24 ports or 48 port switches.
Yeah,
If
like
you
maximum 48 port, right? Like maximum 48 port.
Yes,
Because
so if you are buying a 2 rack unit switch, then you will get a 48 port.
oh,
Okay, so yeah, so they are but yeah, I mean they are not modular, but they are powerful. So some of the key features of this 5000 series switches are like and they can support like I have told earlier, they can support fiber channel over Ethernet. They can support normal RJ45 ports, copper ports if needed, and they will also support SFP on fibers. Okay, so it depends what kind of model you will be buying according to your need. So there are various and different versions of the switches that you can buy from the Cisco side. And obviously, whenever you're trying to design a network, we will have a consultant from the Cisco side. We will help you understand which switches that you will be using according to your need. They are very low latency switches, which makes them suitable for high speed workloads. Like they can, based on the line cards, you can have 25 gig, 40 gigs, and then some maybe 100 gigs as well. So you will find different high speed workload suitable switches here. And they have a very deep buffer models like Nexus. You can have suppose 5, 6, 9, 6Q models are here, and then 5, 6, 1 to 8P models are here, which are good for very bursty traffic, or you can say storage traffic, which sometimes you won't be seeing. When I say bursty traffic, means sometimes there will be no traffic on that interface, and sometimes you will be seeing that there are very high load on that interface. So these switches can handle those kind of traffics as well, and that is why we will be using them in the FCOE connections as well, because from the storage you will be sometimes see loads and loads of traffic are coming in, and sometimes you will see that only some small MBs of traffic are coming in. These are very good fit in mid-sized data centers, or also in large data centers as top of the rack, with having a core with either a 7K or a 9K. Normally 9K, you won't be using it until and unless you will be, you won't be, you will be what we would say running ACI. And if you are running ACI, then you won't be bother using a 5K, right? So the base match is like 7K with 5Ks. And if you're using 9K and trying to do any kind of ACI, then for 9K as well, we have 9800 on the core, and on the on the top of the rack you can have something called 9300s. So if you are running ACI, then all the switches have to be 9Ks. 5K to 7Ks, they don't support ACI. So this is clear up till here. Okay, so then let's move on to this particular slide here. So the 3000 series switch. So the Nexus 3000, it's a it's a it's a little bit peculiar. So which is specially built for ultra low latency application. Like for example, you will often see these switches used in trading, where we need very low latency, ultra, we can say low latency is something normal in data center. You can say ultra low latency, where people are doing high frequency trading and they cannot lose a second to have a latency in order to buy or sell its shares, right? So there where we'll be using very high frequency, I mean very low latency switches. That is what we call as the 3000 series switches. These are not these are not regular Nexus switches that you would be finding in any data centers. Only those data centers which will be handling special traffics like trading, scientific computing, or any kind of low sensitive environments. There you will see this 3000 series switches. Now, what makes them unique? It's obviously these are not modular. Okay, so these are fixed platform with very low latency, sub microsecond range. They don't support advanced features like you FCOE. They don't support this, so that means they don't need to connect to a storage. They have nothing to do with storage. They don't support VDC. All those things are no, they don't support this. NXOS, or what they call it is the merchant silicon based switches. So the the models that they have are 3172PQ and 31128PQ. So all those switches are basically being used for this particular special cases. You won't be able to see them anywhere, and also they are not being used anyway. I mean, you won't be finding, at least on your day-to-day job basis. But
Yeah,
the
currently
get
in my like job profile, we are using 3548 and 311 is
hmm,
80.
right. And the thing is, if your goal is to just have raw switching power, only have you need power and minimal delay, very less delay you're talking about, then this is the switch that you will be needing. Okay. So this is basically how what it 3000 series switches. There's not much use cases here as well. So it is used for financial services that I've talked about earlier, scientific computing, any low latency AI clusters where we are using. So that is where we are trying to use the 3000 series switches. And then the next one is the 2000. 2000 is special one because they are not even considered as a switch. These are what we called as a fabric extenders. Right? The Nexus 2000 series, uh, they cannot work standalone. They are not standalone switches. They are extension of a parent switch, such as the 5000 series switches or the 7000 series switches. Think of them like remote line cards. Right? You want a line card instead of a switch on a rack, then you can put a 2000 series switch. They don't have their own control plane. They rely on the parent switch for all the management. They operate like dumb switches. They can only forward traffic to the upstream parent, and they are only for the forwarding plane basically. They don't do anything else. So they are great for reducing operational complexity, you can say, at the rack level. So when I was talking earlier here, suppose if we have, I'll just show you a little. Suppose here we have two racks, and maybe there is a, suppose this rack is here. Suppose this is rack 1, rack 2, and rack 3. Suppose here is the core we have. This is suppose the 7000 series switch. And suppose here is a 5000 series switch. Okay. Now what we can do, instead of having more budget and put each and one 5000 series here, we can keep a 2000 or with what we call as a FEX, fabric extender, on this Rex. Right? And from here, this FEX will connect to this suppose 5K, right? And all the servers that will be here will be connecting to this 2Ks like this. Okay, and from here it will connect to this core. Here what we have done, this 5000 will now act as an aggregation switch, right? And these faxes are nothing but the 5000 series switch extension. These are basically being handled and managed by this 5000 series switch only, but this they don't have their own control plane.
So then all CPU load, memory load will be there on that 5000, na?
Yep, everything, all the control plane is here. These are only for forwarding and receiving data.
So the CPU utilization will go high, for that 5000.
Yes, obviously. So
Because of
accordingly, you will be, yeah, accordingly you will be buying in higher 5000 series switches to accommodate the number of faxes that you will be using. Sometimes we will be finding here one more fax, sorry, one more 5000 series switch here. For example, we can do something like this. From this 2K, one port will come to this 5000, one port will come to this 5000. Similarly, one port will come to this 5000, and another will come to this. So what here we can do is like create a virtual port channel, right? So that we can have a high redundancy. If one 5000 goes down, the other 5000 can take up. Or if you wanted to bring down the load, you can use the 5000 as an active mode, so that this 2K's upstream VPC ports can be used for both the 5000 series switches. They can load share the loads between both the 5Ks.
Arjun, and if server 1 of 2K wants to communicate to server 2 of 2K on extreme left rack, I'm talking about the rack
Uh,
number 1. So every time 2K will forward the traffic to 5K and 5K will return traffic to S2. This
no, no,
okay.
no. So this 5K, you can think of this 2K is nothing by the 5K's extension. So that means if this server traffic is coming here, right, and if needs to go to this server 2, it depends if they are on the same subnet. If they are on the same subnet and they are on the same broadcast domain, then it will just send the traffic back here from the 2K itself. But if the server is on a different SVI and this SVI is created on the 5Ks, then you have to go to the 5K, then come back for the
Sir,
routing.
it need to
Okay.
go to 5K, na, because that supervisor is then basically that the brain is that 5K, na.
Yes.
How the traffic should move from one port to another port, it will be decided by that 5K, I think.
Yes. So the thing is, when the traffic, let me take a different color here. So when the traffic will come from this server to this 2K, you don't see this 2K a different switch. Think of this 2K is nothing but the 5K only. Okay. So that means, uh, just think about like this. If the traffic is coming to the 2K, right, and the 2K's ports are nothing but the same ports that are here. I mean,
Okay, understood.
yeah. So for example, when you will see later on, when you see, if you do a show IP interface brief later on this switch, you will be able to see all the 2K's interfaces on this 5K interfaces showing up. There is
Okay.
no different IP
Uh,
on this switch
yeah, it is
login.
like it is like we are making a stack in a catalyst.
Yes, so you can say that this is a line card itself. This 2K is just a line card, but instead of this line card putting it on the 5K chassis, we are just taking it out and putting it on the rack.
Understood. Okay. And
Okay.
apart from 5K, we can add like same we can do for the 9K also, no? 9K and 3K.
Yes, yes, yes. We can do it on the 9Ks, we can do it on the 7Ks, we can do it on the 5Ks, anywhere.
3K also.
Yes. So, but no, 3K, yeah, 3K also we can do it. But the thing is, this, I mean, what we say, this basically thing, the way it works is like, uh, if it needs to do any kind of routing, I mean, for example, if this server is on the 10.1 dot, suppose 1.10 IP, and S2 is on 10.2.1.10 IP. Okay. Now these are on two different domains, broadcast domains, right? Two different VLANs. Now, if the traffic comes from S1 and needs to go to S2, then this 2K won't be able to do the routing part. Okay, so in order to do the calculation, the routing, obviously it has to be done by the control plane, right? So then that traffic will go to the 5K, and it will see, because obviously the SVIs are not created on the 2K, because it is not meant to be. All the SVIs will be created on the 5K. So the traffic will be going to the gateway, and in order to go to the gateway, it will take the trunk link and then go to the 5K. And from the 5K, it will see that it is connected to its own 2K on a different interface. Then it will send the traffic back here, and then it will come back here like this.
If both are in different network.
Yes, if they are in different network. But if they are
What
on the
if,
same network,
yeah,
if they're on the same network, then it don't need to go here, because this 2Ks will I mean this because this 5K will have its own MAC table, right? It will know where all the MAC addresses are that are connected to the 2K ports, right? For
no,
example,
no, so that 2K does have VLANs configured? No, na?
no,
No, so that VLAN also configured on 5K only, na?
yes,
Because
it is
that
there.
server 1 and server 2 both are supposed in the VLAN 10. So
Yes,
to communicate between the server 1 to server 2, it must go to 5K to like to check both are in same VLAN or not.
that
L2
will
traffic
be,
go to there only.
yeah, that will be in the MAC table, right? I mean, for example, in the MAC, when you will see the MAC table, you will see that, suppose if you do a show MAC address table, you will see that, for example, this fax number is 128. Okay, so if we have a fax 128 1/1, here we have a MAC address MAC1 configured. 128 1/2, here we have a MAC address 2. Suppose this is for server 1, this is for server 2. Now this thing is already being known by the 5K, that this is here and this is here, right? So if the traffic needs to come from S1 to S2, it knows that it needs to send it to this interface only.
So the traffic is sent as per the MAC address or VLAN.
MAC address, because they are on the same VLAN, right? Then it don't have to come to the gateway.
So how 2K will decide? Both are in
2K will not
VLAN
decide.
10, VLAN. So
Uh,
it must go 5K na, to decide whether it both are in same VLAN or not.
that is already known by the 5K. You are thinking the 2K as a separate switch.
No, no,
Don't
I'm not
think.
thinking separate switch. I'm thinking even it is a layer 3 traffic or layer 2 traffic, that
Yes,
2K will take a permission from 5K whether this traffic must go to S1 to S2 or not, server 1 to server
that is the control plane traffic, and
control plane traffic,
that
right?
is already being known, and the control plane traffic is already there every time. You don't have
So
to go to the 5K to check the control plane traffic.
exactly. So the same thing must be applied to layer 3 traffic also
Yes,
because
but the
that's
layer
already
3,
controlling.
yeah, but the layer 3 traffic has to go to the gateway, because it has to do the routing, right?
Yeah, yeah. Now I got it. It has to go to the gateway first.
Right. And
Okay, to the
gateways are
SVI.
here on, yes, and all the SVs are on the 5K.
Okay, okay, got it, got it.
Okay. Okay. So here we are clear, right?
Yes, yes.
Okay. So these are the fabric extenders, and these are some of the models that we can use on a. There might be different ones as well, but I have just put here two. So these are, you can say, these are all 48 ports. You can see here, based on the, and later on when we will be doing some more models, then you will be seeing that based on the number itself, model number itself, you will know how many ports that they have. What does the T means, P means, E means, U means. Every letter is having their description, right?
Yeah, one more,
So
sir. Suppose one of these, suppose 5K or 7K or 9K, the
uh
port are all are 100 gig ports, suppose.
yes.
Okay. So if I add this 2000K as a flex, so does all the port of this 2000K become 100 gig port, or it will be
No.
like little less port, less?
Yeah, I mean, based on the 5K that you will be buying, it will have their own bandwidth for each port.
Yeah, 5 port, like I buy 48 port 5K switch. 48 ports are suppose 40 gig port. So if
Right.
I add this 2K as a flex, that
Hmm.
remain in that 2K there are 28 ports. That all 28 ports will become 40 gig.
Yes. So if you are buying a 2K with suppose 48 ports, and each 48 port is having a 40 gig, right? Then each port bandwidth is a 40 gig on the 2K. And on the 5K, if the 5K is running 100 gig, so obviously we want that 100 gig on this uplink port,
Yes.
right? Right? So it is, yeah, it works like that. So this won't be, this will not become 100 gigs. This will remain as 40 gig only. So
And between this 5K and 2K, do we need to
mhm.
configure something like or it is a plug and play?
Oh, the 5K, no, we have to configure it. There will be a separate configuration for faxes. So we have to configure them accordingly. So based on this naming structure that you can see here, so this T means this is a copper. Okay, that means it's a twisted pair. We can say for T stands for twisted pair. It's a copper port, and P means it's a 10 gig. So all the 48 ports on this Nexus 2K are copper and 10 gig. And E means enhanced. So it can support something more that the normal TP doesn't support. So similarly for this one, this is a 48 port. This is untwisted pair, and this is P, again 10 gig, and Q means it supports 40 gig as well. So that means um, it will have some ports of 10 gig and some ports of 40 gig of these 48 ports. Okay, so later on we will be looking at some of the naming structure of the models and how we can see what it defines just by looking at the part number. But we
Sorry,
will,
Arjun.
yeah.
Sorry, Arjun. What did you say the U in that model number? What is the meaning of the U?
It's normally it's twisted pair only, but unshielded. So no, I mean basically when we say U, I mean it's a copper only, but a different type of copper you can say. But
Okay.
it's related to copper only. So and for P, there are different namings for P, Y, Q, L, C, D. So all those letters have different. I will give you those letters later on. when we will be covering on. But yeah, every letters will have its own naming, definition of what kind of throughput and what kind of bandwidth throughput it can support.
Okay, thank you.
Yep, no problem. So let's clear this up, finish this. Yep. So these are the 2K. And next is, I think we have almost covered all the things here. So we have covered what we have covered the 7,000, we have covered the 5,000, 3,000, 2,000. So these are the ones that we use a lot. So if we recap a little bit, so the 7,000 are the ones that can be used on the core. They are highly scalable, modular form. These are modular switches. Then we have the 5,000 series switches. These are fixed, these are fixed switches, which cannot be expandable. And these are something that we use in the top of the rack or on the access there. Then we have the 3,000 series switches, which are also fixed switches that cannot be extended. These are very low latency switches that can be used on the access layer as well. Then we have the 2000 series switches. These 2000s are also fixed. We cannot expand them. They are not modular. And then these are basically used for port extension, or you can say fabric extension. Okay. And yeah, so these ones are the one that can support FCOE technology. These are the ones that can support FCOE technologies. This is the one that cannot support FCOE, and this depends whether the parent switch. Oh no, sorry. This 2000 itself, each ports cannot do FCOE. If you have to do FCOE, then you cannot connect the SAN network on a fax. You have to connect the SAN directly on the 5000. Okay. So, so some of the use cases we have already seen where we can use them for ultra low latency. We can use it for the trading. We can use the 3000 series switches. 7000s are basically on the cores, and 5000s are on the aggregation fixed, and on 2000 are the extenders. These are basically an overview of all the Nexus platforms that we have. So I just have some quick questions. So this is that you are all listening to me. So I would I would believe that you have get some kind of knowledge from my side. So I would just like to know. I will just put up 5 questions, not much. Then very simple questions. Uh, just let me know. So which Nexus model supports VDC?
9K and 7K.
And 9K cannot support it. Only 7K.
Oh.
The
So we
VDC,
cannot, sorry, we cannot create VDC on 9000
nope,
series.
nope.
Okay.
VDC is only limited to 7K. When the 9Ks were built, Cisco removed VDC. They don't
And what is the
even
alternate?
on the 9K.
Yeah.
I think there is a separate thing for the 9Ks that we can use, but but for the VDC, it is only on the 7K. We cannot use it on the 9Ks.
And VPC is still there?
VPC is there.
Okay.
VPC is there, but the 7K is only one that uses VDC.
Okay, good to know. Thank you, Arjun.
Yeah, yep, no problem. And the next question will be which series of functions, which series of switches acts as a fabric extender?
2000.
2000.
Yep, that will be the 2000, or what we call as the fabric extenders. Which series is used as a very, if you want them as a very in an ultra low latency environment, which series of
3000.
switches?
3000.
3K.
3000.
Yep, 3000. Which series of switches offers very deep buffer and unified ports. For example, um, we can say like they have a very the I mean the buffer that they use. So when that they use are very deep.
It's 5,000.
Yep, yep. Just explained earlier, because when we will get some bursty traffic, we will be need a very deep buffer so that it can store it. Okay.
Deep buffer means the memory.
Deep buffer means each interface have its buffers, right? So it is what we call the uh, uh, basically, for example, we have a queue, right? We have a it is called in the QoS term, we'll call it queue. So these buffers are basically what if any traffic comes in, then it will, instead of losing, or instead of dropping traffic, it will try to put it in the buffer, so that when the when the bursty traffic gets a little bit of uncongested, that buffer will be cleared up so that it doesn't drop it. Okay, so and okay, so for the Nexus 2000, does that have their own control plane?
No, Nexus 2000 don't
No.
have the brain. It
Okay,
will work. It will depend on 7K and 5K.
okay, great, great. That's good.
Five.
So yeah, I think you guys have got it what I have said right until now. So that brings us to the end of this session actually. So if there are any questions, you can feel free to ask me. And if you don't have any questions, then I will extend this extend my mantle to the next person, who will be his name is Hari. So he will be able to give you more detail on this particular session, and not on this session but on this course, and he will also give you some idea about the labs and the lab that we will be, and we will be giving access to the labs as well so that you can practice. So I will ask Hari to give you those details. So if you have any questions on the course and on the lab, you can ask him. And if you have any questions related to our session, then you can talk to me.
So, how many sessions we require to complete this Nexus course?
There
If you
will
just
be, let me see. So there are a total of 15 modules. This is the first module that we have discussed today. So you can say 14 more modules to go.
okay. So each module required on only one day, or it will extend 2 days to 3 days.
I will try to complete it in one day, so that so that we can keep on track and it becomes less boring. But if you have more, if you have more questions and need to understand it better, then we can extend it as needed.
Yeah, no
How
problem.
much time? How much time Nexus will take?
We have a model of 14 days. So I mean,
Okay.
we have 15 modules. So this is the first module, the overview that we have completed today. So there will
Okay.
be 14 more to go.
And what about ACI?
Sorry,
What about ACI?
ACI will be a different course, which can cover later on. This particular course is only related to this Nexus switching.
Okay.
You have
So,
not
sir,
defined any
to
numbers of
cover,
hours.
Sorry,
Do you have total numbers of hours to complete all these 14, 15 modules?
I have taken. I will be taking around 2 hours for each module.
Okay.
Do you have an outline for what's to be covered in the 14,
Yeah,
the
we can
14
share that.
modules?
Yeah, we can share that agenda with you in a PDF format if you need. So we can give you
and
all the modules.
yeah, as we cover all the session day by day, so so can we get the notes also from you? Or how,
Yeah,
what about the notes? Yeah.
yeah, we can share the notes as well.
Okay. And sir, can we cover the multicasting, all these things in this course? Multicasting in
Yes,
the next step,
yes, yes. We
and
will cover multicasting.
VXLAN,
Yes. So
VXLAN, and all these
yeah,
things.
I will just say out all the module names so that you can have some understanding what we will be covering. So the first one is the platforms that we have covered today. Next, in the next course, I will be going through the 9000 series switch. I will give you an overview of how the Nexus 5000 works and its traditional, the spine and leaf technologies and overlay topologies, how it works, and a brief idea of how the ACI combines with the 9K. So I will just take one module for that one because ACI is a very vast course on its own. In order to cover that, we will be needing a separate course. So in the next module, I will just go through an overview of the ACI and the how the 9K plays its role on it. And then we will be covering on the Nexus softwares, the licensing models, and then we will be covering the different platform, the different options that we'll be using to access the Nexus, like GUI, then the CLI and all those things. And then we will covering one module will be dedicated to VDC, then one module will be dedicated to VPC, virtual port channels, then one module will be dedicated to switching protocols, then one module is for where is that? One module is for redundancy, like first or redundancy protocols, not the actual switch redundancy. For that, we have a different module. For next one module will be routing. Then there will be another one for overlay protocols. Then there will be a VXLAN, multicast, infrastructure security, HA for the switch itself, and the last will be for programmability.
How do we get registered for these?
Sorry?
Or get input?
Can you say again?
How do we get registered for these modules and training coming up? And this
Yeah, I
was the
think
first
for
of it.
for that one, you can talk to Hari. He is from the management, so he will be able to guide you through the how you can enroll yourself on the course.
Question.
Yep.
Of the modules that you just covered, the interoperability in the lab, is there anything that production-wise or in the lab that can be duplicated in what you're covering?
Duplicated where by yourself
In
on
other
the
words,
lab.
yeah, so the lab that you guys offer, is there
Mm-hmm.
any of the modules that you'll have labs for which
Mm.
we will not be able to complete because the lab is virtual or
Till now, I don't see anything that could restrict on the lab itself to go through all of this. Because these are all on the 7Ks or the 5Ks that we will be covering. So except for the ACI specific one, which cannot be covered on a simulator, we have to get that at the Cisco emulator for that one. But apart from ACI, I think we will be able to cover all of them.
so how will we get training on the ACI then?
For ACI, there will be a different course actually. It is not covered on this particular Nexus.
Gotcha.
In the broadcast message, it was mentioned Nexus plus ACI plus SD-WAN.
Yeah, so it's a whole, you can enroll yourself on all the courses, or you can take different courses one by one. So it's up to you. So maybe Hari can be able to explain it better on that part. He's from the management, so he should be, let me say, he should be here, by the way. Hari, are you here?
Oh, yes, sir. Yes, Arjun, I'm here.
Okay, yeah. Can you take this up?
Yes, yes.
Thank you. Yeah, yeah. You can ask any questions to Hari regarding the course enrollment, guys.
So, hi, hi, guys.
Hi, Hari. Could you
I'm
please walk
yeah,
us?
yeah. You can see my screen, right?
Yeah.
Yeah, I'm thanks Arjun for letting me be. I'm Hari, as I told you. I'm from the management part, and I'm here to give you a brief about the SDN orchestration course regarding the schedule, lab, and fee. Okay. This is the session, first class session we had for the orchestration, SDN orchestration. We had started off with Nexus. Okay. The classes will be held on Saturday and Sunday, that is weekends only. The timing will be from 9 p.m. to 11 p.m. IST, Indian Standard Time, that is. The overall course of SDN that includes Nexus, SDWAN, and ACI, that will be for the 4 months of duration. Okay. And regarding to the enrollments of this course, whatever the sessions are happening, all the sessions will be recorded and it will be in the portal and will be given to the access to you guys, and you will have it for lifetime. Every class is a record in that means. And we are providing 2 labs to you. One is a remote, another one is a home lab. For remote lab, you can use it for 24/7. There is no limitation on that part. And you will get individual labs for ACI, SD-WAN, and Nexus. That is for 3 individual months. We are starting off with Nexus now. So we will be giving you a Nexus lab for next 3 months. When ACI starts off, then we will be giving you the Nexus lab, the ACI lab for next 3 months. So totally you will have 9 months of labs, three each of for every course. And regarding to the workbooks, a workbook is what we call it as the stepwise procedure of whatever the classes has been taken, whatever has been done on the class. Everything is recorded in the step-by-step manner. Okay, and it has been put in the screenshot so that the learners can follow the workbooks and do their labs as well. So that is what we call as workbook. The step-by-step material, everything will be given. Okay. And regarding to the home lab part, we will be sending out the home lab to you. You can download that, and once that is downloaded, our team member will be interact with you and set up the lab on your own machine, so that you can use it for a lifetime. Where the remote lab is only for 3 months for particular course, in the sense of Nexus, ACI, and SDWAN, whereas the home lab, it depends on your machine's configuration, where you can use it for lifetime. It will be on your machine.
And
And to
what
set up,
will be the minimum configuration required for that lab?
yeah, each course differs with it. Nexus
Sorry?
differs, ACI differs, and SD-WAN differs. Okay,
Okay.
ACI it requires 32 GB RAM, and
Okay.
32 CPU. Whereas SD-WAN is a different configuration. It needs 16 CPUs.
16?
16
16
CPUs.
CPUs, okay.
Yeah,
16,
yeah.
16, 1 6.
And for Nexus, yeah, 1/6. I will share you the details of that.
Means if
What
we have
course Nexus? How many
if we have 32 cores of CPU, then we can run
cores?
any
Yeah,
lab.
core. Yeah, yes.
Any version of ACI or what? Like,
It runs on all Nexus, ACI, and SD-WAN. All it runs. If you have a higher configuration, all it runs. We can run all the three Nexus, ACI, and SD-WAN.
Okay.
And coming to the lab configuration, as I
I
told you,
think
home lab. Yeah.
I think ACI doesn't support on the simulator.
Yeah, a simulator. We will give you the ACI simulator from our end, the remote lab, that is. You can use it from our end only. We will be providing the
Not the
remote
home
lab that
lab.
you don't have to worry
It's
about.
not for the home lab. ACI
Home
is
lab,
not for the
yeah,
home
home
lab.
lab, it doesn't support much on the machine, so we will be providing the remote lab for that. And regarding the assistance, you will be given the support DL where you can raise a ticket, and backend team will be supporting you 24/7.